thank you so much for the introduction, and thank you so much for the invitation to this session. I'm very glad to be here. My talk is really good because it's right before lunch, and I'm going to talk about actual eating. So hopefully it will build up some appetite and will be a little bit educational. So to start, as you know, the problem of monitoring of diet and nutrition is a very difficult one, right? We just had a coffee break. Do you know how many calories you consumed, how many nutrients you consumed in that break? Anyone? All right, so that's a difficult problem. And that's part of the problems that I'm trying to work on, and these are my disclosures. So when we're talking about nutrition research, there are many, many questions, but some of these questions are like, can we determine when people eat, right? Just do detect passively. Can we figure out what is being eaten and how much are we eating? We can also ask question is, how we eat? Do we eat socially or individually? And we can also ask question, why exactly we eat? Is it a physiological necessity at that moment of time, or is it a psychological reward? We can also try to change eating behavior. And my lab does work in all of this, but today I'm just going to talk about top 3 topics. And I'm going to give a very broad introduction of the field, not just specifically my work, though I'll focus on some aspects that my lab does. So my goal today is to show the role of wearables, images, and AI in analysis of diet and nutrition. So the wearables carry the promise of passive detection of eating and drinking. That means being completely transparent to the user. Because it's a wearable, you know how we use a fitness monitor, we can also provide the feedback, right, to the user through the wearable or through some other application. I'm also going to cover the images because images of the food is one indirect way to measure diet and nutrition. And then obviously AI carries the promise of automatically analyzing sensor signals and images and interacting with the user. So we'll start with the wearables. Wearables are primarily there attempting to perform this sort of passive detection of food intake. And if we look at the lifespan, right, when we are just born, there is one type of food we're consuming, this is milk, and infants are either sucking the milk breastfed or bottle feeding. In either case, it's sucking movement and swallowing of the food. And there are a variety of sensors that we can utilize to measure that in infants. And then the baby begins to grow up, and there are 2 significant changes. One change is fine motor skills. And with the fine motor skills, babies begin to take food into their mouth, right? So it's no longer only milk, it's more solid foods, and they're brought into the mouth. And another important change, they develop dentition, and now they can chew. And all of this could be used as proxies for automatically detecting when the person is eating. So imagine if you want just to capture those moments when someone is eating. And I'm going to give a very brief overview. So one way to approach this is this hand-to-mouth gesture monitors. And you see some work from Adam Hoover, and it also can be implemented as a smartwatch. And we all know that these bands have very high social acceptance. You know, people wear watches, fitness bands. But they have fairly low accuracy. So if you want to monitor somebody's eating, this is available right now. They have fairly low accuracy for a variety of reasons, because napkin to your mouth looks exactly the same as the food to your mouth. Or maybe we've also studied smokers, very similar gesture. Obviously, they don't provide insights into the types of food being consumed. There are swallowing monitors, and you see some examples from the research literature, and it's a very reliable way to detect food because swallowing rate goes significantly up when people are eating compared to resting state. So it's very, very accurate, but it has very low social acceptance. When we were experimenting with these monitors, it it was very hard to find someone who would be willing to wear it for a day. I mean, it was virtually impossible. And there are also chewing monitors which monitor chewing muscles, especially temporalis muscle, which is in your temple. And it's a reliable way to detect food and beverage consumption. And it's more socially acceptable than a swallowing monitor, similar to other wearables. Does not give you really insight about what type of food is being consumed. So what can we do with these wearables? Well, actually, even though we don't know what the person is eating, they can provide, again, a passive way to monitor someone's eating habits. So what you're looking on this graph is 1 week from one person's eating. And each blue bar represents an eating event during this day. Sometimes you see 3, sometimes you see 4, sometimes you see more. It really depends. And that's a convenient way to look, again, at the eating patterns, timing, and duration of the episode. Now, because you can think if you eat more, you chew more, and you swallow more, right? So there is some sort of correlation between hand gestures, chews, and swallows. So you can estimate a little bit the consumed amount. You can also look at the microstructure of eating. So what happens within each of these eating events? Because normally just you start eating and you end eating. But what's in between, like how fast you're eating, how many bouts you have, and so on and so forth. You can use sensors to look into this. But the most important piece of information is still missing, and that is what exactly you're eating in there. Because people ask me, are they eating like a head of lettuce? Nobody eats a head of lettuce, but exactly what is it? So that's why people have used images for a very long time. You see a paper from 1983. They had to carry a film camera, and the film had to be developed and pictures printed. All right, so since then, obviously, there was a lot of progress, and people have used stationary cameras, instrumenting places, portable cameras, and obviously now the smartphones, and also a variety of wearable devices that potentially may take images of what you're eating. So like in my lab, we developed one of these devices. It's called automatic ingestion monitor. It's shown in here. I have it with me, and if you want to take a look, you can take a look. So it's a passive wearable device which has 2 important features. First of all, it has a sensor to detect eating. So it can passively detect when you're eating. And then when the sensor thinks that you're eating, it has a camera, and it will grab an image of what you're eating for further analysis. So it combines the benefit of having a wearable, which is again a passive instrument, with an imaging capability that will allow us to look at the food itself. This is what the an eating episode captured by this device looks like. So on the bottom graph, you see this, let's call it chewing sensor. It's not really chewing, but temporalis muscle activation sensor. And in this sensor, you can see that, for example, there are some strong activations in this area, and the image series is time aligned. So you can see the person is drinking here, and there is a pause to put some ketchup, so there is no eating in this time, and then you see a lot of chewing and consumption. So this is kind of a picture we get from this device, where we have, again, the sensor describing the eating process, and then we have the images describing the eating process. So what do we do with the images, right? Whether you use a film camera or you use like an automatic camera, what do you do with those images? Well, the very first thing which comes to mind, you can take a nutritionist, you ask a nutritionist and say, please take a look at this image and tell me what the person is eating and how much of it is being eaten, right? So that's a very natural thing to do. And again, this is one of the earlier work in this field by Corby Martin from Pennington, and they've done exactly that. So they used a camera to capture images. As you can see, the food is nicely staged in here. And here is the graph of energy intake. And as you can see, so this is Bland-Altman analysis. And as you can see, well, it's not particularly accurate, right? So the reason is like, the question is, why is it not particularly accurate? And I'll try to shed some light into this. But then another idea which comes to mind, why don't we use AI to analyze the images? Maybe it can be more accurate than human. So let's take a look at what happens when AI attempts to analyze an image. And there is a lot of literature to this. So let's say we start with an image captured some way, and there is food in it. What do we need to do? Well, first of all, we need to segment this food from the rest of the scene, right? Because, like, imagine if you're eating right now, you may have like notes, you may have hamburger next, and a cup, and so what, the pen. So it needs to be segmented. And then in that segmented image, we need to recognize individual food items. But that's not enough, because not only we need to recognize individual food items, we need to figure out how much is being eaten. So we need to estimate volume or portion size of that food item. And then again, as I mentioned, images are not a direct measurement. We are not putting this stuff in mass spectrometer and measuring, individual molecules. So we need to relate this to a database and hopefully get an accurate estimate of the energy content and nutrient content in the food being eaten. So as you can see, that's a lot of steps. And the errors may originate in misidentification of foods. The errors may originate in errors in volume estimation. The errors may originate in matching with the database. So a lot of sources of errors that are possible here. So let's talk about food detection and recognition. So again, let's say we capture an image. There are several issues to be addressed. First of all, we need to figure out if there is food in the image, period. So especially with the wearables. Like, we have an automatic way where we simply delete any image which does not have a food in it, because we don't need those images, and that's important for privacy protection, which I'm going to talk. Now, let's say we determine that there is food in the image, then we need to figure out where in the image this food item is, and we want to identify the type of food item. And that's where it says AI. So a lot of methods of deep learning, such as deep neural networks, convolutional networks, vision transformers, you name it, are targeting this specific task. So you'll see a lot of work in research literature where people just try to identify foods, and it's a very difficult, challenging task just because of this great variability of foods that we have around us. Then another issue is portion size estimation. So this is not like Photoshop. This is a real image. It's called forced perspective, because in monocular camera vision, object size is dependent on the distance to the object. So the farther away looks smaller, closer looks bigger, but again, it's monocular and cannot really make the difference unless you know the difference, the distance to the object, okay? So that's why in many studies involving food images, people place fiducial markers in the image. It gives an angle to the scene. It also gives the plane in which food is located, and it serves an estimate of a distance. But overall, it's a challenging problem, and there are many different methods of artificial intelligence which attempt to use methods of artificial intelligence to provide depth maps and estimate volume. And here is some summary table from different studies. If you look at this, and it's probably small, but some studies have very limited amount of foods, like 3 food items, 10 food items, 10 food items, 11 food items. So first of all, this is a field in its infancy, let's put it this way. Not only that, if you look at the errors are pretty high. So 22% error in this one, 33, somewhere around there. So it's very high error. And obviously, food portion estimation is a challenging question. And that's what we find with human nutritionists as well. So the major contributor to the error of, let's say, energy intake estimation comes from errors in portion size estimation, because it's a very challenging problem, even for humans. So, but that's not it, because as you can see here, the image of the food is like really nicely plated, it's right in front of you. We're dealing with wearables capturing images in real life. And believe me, this does not look anything close to this. I mean, because foods are not staged. You see people eating in cars. Do you know how many people are eating in cars? Like a lot of people are eating in cars. I don't know if it's completely legal in many states, but people are eating on the go. I mean, like literally on the go, like walking somewhere. I mean, in this extreme case, that's from our study in Ghana. The lady is just taking a plate and walking with the plate somewhere. But you see people eating ice cream on the go, right? Imagine it's like 2,000 calories. I'm just carrying them with me. And of course, shared plate eating. You go to any Tex-Mex restaurant, right? They put salsa and chips, and the family begins grabbing them. So very, very difficult in life where it's not staged. So that's a challenge. Another challenge is compliance, because when we are talking about a wearable device, we want to know if the person is actually using the device, wearing the device. How do we know? So like for our device, we developed a method which estimates whether the person is using the device. And so this is a report from a few days from a real study. And white means the device is not being used, green means charging, blue is compliant wear. So we know a person is using it as prescribed. And red one are eating events. You can see we have some late night eating events which go into the next day. And white here is perfectly fine because we ask people to take the device off for privacy reasons. So if they have some private situations, they can take it off. And that's my next challenge, privacy. Because use of images carries privacy concerns. What are you capturing? How people are caring about this? There are ethical guidelines specifically for use of egocentric cameras. That's what we're talking about, egocentric cameras in human subject research, which we always follow. But in addition, we also create this additional protections, as I mentioned, eliminating all of the foods, all of the images which do not have food in them. And then in even food images, we eliminate all people and all screens before it goes for any sort of nutritional analysis. And finally, the major challenge, I mean, image is not perfect. It's not a direct measurement of calorie, volume, or nutrients. It's an indirect measure. It's a proxy. What's in the glass? White liquid, right? Okay, so it could be this white liquid, it could be this white liquid, it could be this white liquid. Oh my God, it could be one of those. So we're actually working on some solution. I'm not going to tell how, but we're working on some solutions trying to solve this, but it is a challenging issue, as you can see, because that leads to the error in food identification, right? So if you make an error in the food identification, that's also a very significant challenge. Well, anyway, but I don't want to finish on challenges. I want to bring up the opportunities, right? So the opportunities, when we combine wearables with images and AI, what does it give us? First of all, we can detect eating as it happens in real life situations. That's important because it's quite different from staged and force-feeding studies. We can recognize food, estimate portions, and nutrient energy content. Something that I did not mention, but we can provide real-time feedback because we can crank this information in real time. We can get it back to the user. Soon somebody will get some augmented reality glasses, right? And so everybody in this room not will be using your smartphone, but will be sitting and looking at a virtual screen somewhere else. And that virtual screen may potentially carry information about the food you're eating. And AI models like ChatGPT, they can talk to you. They can convince you, oh, you probably don't want to eat that donut. I mean, like, it's really bad for you. Or maybe, I don't know what sort of, I'm not a psychologist, what sort of motivation to use. Anyway, so key takeaway. Why wearables? Because people are willing to use them, and they allow for passive detection and quantification of eating. Imaging is the current to-go way to know about food being eaten. None of this is possible without machine learning and artificial intelligence, because all of this is based on some sort of machine learning technology. So in our device, we have a machine learning algorithm running on the device to decide when to take a picture. Without that, battery life is non-existent. Nothing is perfect, and there is room for improvement. This is a growing field, and we hopefully see some improvements very soon. And there are ethical and privacy issues which go along with the food measurement issues. So that's pretty much it. I would like to think I did not have a nice colleague. I have so many colleagues. I would like to appreciate them all working with this under me, NIH support and support from Bill and Melinda Gates Foundation. That's it.